Alright, today we're going to talk about direct and inverse variation. And the way that you could have known that before I told you was, it's the title of the worksheet, right? Direct and inverse variation. Plus it's in the lesson plans that you have already written down from the board, correct? Excellent. So let's go through some of these problems. We're going to go through the problems first and then we're going to discuss them. Okay, but we need to get some data to begin with, so let's go through the problems. A square with a side length x units has a perimeter of y units. So how would we go about finding perimeter? Add up all the sides. Specifically, how do we find the perimeter of a square? Y equals 4x, right? Yeah. S if the side was s, but our side is x, so we would just say 4x, right? Okay? So if x is 3, what's y? 12. And how do you know that? Because you multiplied it by 4, right? Okay, so then somebody tell me 7.5 and somebody tell me 9.5. Let's use the properties that we just talked about. What's 7 times 4? 28. And then what's half of 4? 2 more, so this is 30. See, we didn't even need no stinking calculator. What's 9 times 4? 36. And what's half of 4? 2, so 38. I mean, you can check my math with your calculator, but, I know it's right. Okay? Alright, what about this one? The rectangle with a length of x units and a width of y units has an area of 60 units. How do we find area? So x times y equals 60. Well, that's all fine and good, but what if I want it y equals? Oh, divide both sides by x? Okay, so y would equal what? 60 divided by x. Good. So when x is 4, what's y? Good. 15. When x is 8, what's y? Yeah, some of you are using your calculator. Good job. I know this is 5. What's 8? 7.5? 7.5? Okay. Good. Alright, what about the next one? A man 5 foot tall casts a 3 foot shadow. At the same time of day, a tree y feet high casts an x foot shadow. Just for the record, people in earlier classes were sad for this man. Because he's only 5 feet tall. I told them that was... I appreciated their generous spirit, but we shouldn't make fun of a man who's 5 foot tall. Because he could be a perfectly nice man. Yeah. We don't need to judge people just because of how tall they are. Right? Okay, good. So what kind of equation do we have? This is a little different, right? We maybe need to do some little side work first. Do you know how to solve this problem? Pythagorean theorem is one possibility, but we don't really you need it here. Because we don't know about stuff here. We're not looking for this diagonal right here. We know length and height is what we know. But it's a good guess. We could, or we could just use a ratio, right? A proportion. Couldn't I do that? So I could say the height over the length of the shadow equals the height over the length of the shadow. And then I could cross multiply, right? If I cross multiply, I get 3y equals 5x. And how would I solve for y? Divide by 3. So y would equal what? Yeah, 5x over 3 or 5/3 x, right? Excuse me. So I know this one off the top of my head. I can do that one. What about the other two? .5 is 7.5. Excuse me. And then what about 10.5? What is it? Thank you. 17.5. Okay so far? Okay, what about this one? A person 60 inches tall looks through a mirror 30 inches from the wall. If she's X inches away, how far Y up the wall can she see? Well, it's funny because I didn't really feel sorry for this person. Why? Yeah, it's a girl. Girls are allowed to be 5 feet tall. I told them that was pretty judgmental and strange, but whatever.